Hey everybody, it is Mrs. Gauthier here, and we are working on Chapter 6, Lesson 1 of 1, or 611. All right, so the first thing that it's going to ask us is to describe what moves you could use to create a transformation of the original image shown at the right. So it shows us the original, and then it shows us where it wants us to get the figure to. Now, if you're not sure what a transformation is, look for my video in the resources part on my website for some detailed stuff about that. If you need to go back and refer to that video, please do so, because I'm going to assume that you know what that all the three different types are between a translation, rotation, and a reflection. All right, so in order to get my original figure up to this spot, I know for sure that I'm going to have to reflect it because just sliding it is not going to do it. So I could start, there are two different ways I could start. I could start by sliding, or I could start by what we are going to call flipping. Those are like the slang terms for the official words. So I'm going to start by my flip. Okay. When I flip, I'm going from, I'm going to flip it across the x-axis. Okay. So that means I'm going to count how many boxes I am from the x-axis to my original, or my first point, right? I kind of have these points on the end of our figure here, so you can draw those in if you want. So I can see I'm 1 away, right, on this x-axis. So I'm going to go my x-axis, and I'm going to, instead of going down 1, I'm going to go up 1. And that's where my first point of my triangle, or my corner part, is going to be. I'm going to do the same thing with the next point. So I can see, I'm 1 down, right, from the x-axis. So for this point here, I'm going to move 1 box up from the x-axis. All right, now to get this point down here, I need to count how many boxes down am I going. 1, 2, 3, it looks like. So from my x-axis, I'm going to go up 3. 1, 2, 3, and that's where my first point is going to go. Now with Chapter 6, we have to be super careful and precise because it is very easy to make mistakes with our graph paper. All right, now that I have my 3 points, I can go ahead and connect them. Make sure that you do connect them. Otherwise, you don't have a shape there. And then, okay, so now it looks pretty darn similar. Right now, I'm going to probably slide it. But first, I'm going to show, like, write out what I did. So I reflected it, reflected my shape over my x-axis. It's important to remember you can reflect a shape over any line. You just have to tell what line it is that you're reflecting. Okay. All right. The next thing, I do need to slide it over to get it into place. So I am going to translate or slide. You can use either word. Slide over. And which direction is important? So I'm sliding to the right. And now I need to count how many boxes, essentially, I'm sliding over. So I'm going 1, 2, 3, 4, 5, 6, 7. It is also important that it's not just sliding over till you hit the shape, right? I have to take that point, and wherever it is on my new shape right here is where I have to slide it over to. Okay, so that's why it's over 7. We can double check. They should all be 7, but we can double check. This point here, 1, 2, 3, 4, 5, 6, 7. Yep, that gets me to the same point of my shape. Okay, and I could do this corner too, but it's going to be the same. Just take my word for it. By the way, if you hear a cat meowing in the background, that would be my cat Rika, and she is very upset that I'm not letting her come in and do the video with me today. So that's what that is. All right, so that's how I moved my shape. Now, for 6.3, it says to review what you know about graphs as you complete parts A through D. So part A, finding an equation of a line graphed at the right. Well, I'm going to look at my line here. Remember, y equals mx plus b. All right, now that I have that, I know I'm going to have y equals in my equation. My m, remember, is my growth. So I need to find some lattice points on here. I don't see any drawn already, so I have to find some. That's where the little crosshairs are. Remember, we wouldn't want to pick like this point because it's right in the middle of a box. That's a decimal. I don't like decimals. So I'm going to pick whole numbers. So I like that guy. Ooh, and here's one down here. Right there. All right, I'm going to go ahead and draw my growth triangle so I can see that growth happening. I can see I'm going up 2 and over 1. So my growth would be 2. So 2. Then I need to add my x, right? And then my y-intercept. Where is it crossing the y-axis? That's this point right here, which is number 1 on the y-axis. So I'm going to say plus 1 for my rule. So that would be the rule for that graph. All right. What is its x-axis or x-intercept and y-intercept? So the x-intercept is where it crosses the x-axis, which in this case is not at a whole number. So we're going to have to approximate. But we can see that that is halfway. So that would be 1/2, right? So with our x, that means we're moving over. I'm just going to do it as a decimal, 0.5. And we're not moving up or down at all, right, at that point. So it's just going to be a 0. This is for the x. For the y, we're looking at where does it cross the y-axis. We had to use that up here, remember? So we didn't move left or right at all. So that's going to be a 0. Then when we look at how many we moved up, it was just 1. So there's our point for our y-axis. All right. Graphing the line. That's interesting. Hold on. Oh, okay. Got it. I was wondering, I was like, why do we have to graph the y or the line? It's already right there. Well, 1, they're trying to see if you can graph, and then 2 down here for part D, we're going to need it. So we need to create a little coordinates and give us some axes here. So we have a y-axis, we have an x-axis. I'm just going to use it by like 1, so I'm not going to label my whole graph, but I'm going to go by 1s, and I'm going to let you see it too. Wouldn't that be nice? All right, so in order to graph, I am just going to use my rule to graph because I think that's way easier. So I'm going to again start at my y-intercept. If you need a little review, we start at that y-intercept of 1, and we are going, oh, and you know what? Our growth over here is not positive. It is negative. Good catch, Mrs. Gauthier. Thanks, I know. All right, it is going to be negative, so this is -2. That means we are going up to 1, 2, and over to the left 1 to make our line negative. Okay. That means also we can go down 2 and over 1. I need you to have at least, like, let's just put 5. 1, 2, over 1. I'm just going to, like, so we have enough here to see our line, right? And then I'm going to connect my points, right? Because in order to have a line, we need to have points that are connected. There we go. Okay. Now that we have it graphed. Number D says, on the same set of axes, graph a line that is parallel to the line that you just graphed that goes through the point 0, 0, or the origin, and find the equation of the new line. Okay, so for sure we know it's going through 0, 0. Now, how do we make sure that a graph or a line is parallel? Well, we know it's going to have the exact same growth every single time. So that means my growth, right, in my equation up here was -2. So that means I'm still going up to 1, 2, and over 1. And yes, it looks very, very close to your other line. I realize that. Up to 1, 2, over 1. But it will, even though it looks like it might touch, it will never, ever touch. It is going to go on forever. 1, 2, and never, ever touch. It will always stay very close, right? But still never going to touch. Okay, now it asks for the rule of this line. Okay, so the rule. Y equals, what is the growth? Well, remember, the growth is the same as the other rule. So we know our growth is -2. Then we have our x. Now, for our y-intercept, it did tell us, right, where it's crossing the y-axis. It told us the origin, which is 0, 0. So I could say +0, or I could just leave it off because it's 0, so we don't have to include it. So y equals -2x. Okay, next page. Flipping it over. On to the next problem. All right, which equation below has no solution? Do not just guess. You need to show your work and explain, like I'm going to. All right, when we're solving for a variable, remember we're always dealing with our parentheses if there are some. So in this first one, A, we have parentheses. B, no parentheses. That's kind of nice. All right, so parentheses, we need to distribute, right? Everything outside of that parentheses that's right next to it needs to be distributed to everything inside the parentheses. So that means I'm multiplying 4 times x, which is 4x. My 4 times 1 is 4, 1. So, how about is 4, 1? Is 5 when I multiply. Blah, blah, blah. I wish I had a little backup button on my video recording. How about 4 times 1 is 4? Yes, I do teach math, everybody. I got it. All right, 2x plus 4. Just like that. All right, now I'm trying to isolate my variables, so I need to get my variables together. I like having positive variables, so I'm going to subtract 2x on both sides. Otherwise, I would end up with negative 2x on this right side, and I would prefer positive. I like positive numbers. What can I say? All right, 4 minus 2 is 2x plus 4. Some of you are probably like, oh my goodness, Mrs. Gauthier, just do the math already. All right, I'm working on it. Minus 4 on both sides, right? Isolating that variable. So 2x is on its own. What do we do when there's 4 minus 4 is 0? Well, guess what? We just put a 0. All right, then we're going to divide, right, to get our variable by itself, dividing by that number in front. X equals, let's see, 0 divided by 2 is 0. Okay, so does that have no solution? No, it does not. That is x equals 0. Okay, do not say that that is no solution. All right, next one. Let's try this. Over here, we don't have any parentheses, right, to contend with, so that's awesome. We do have some combining of like terms that we can do. So let's do that first. We have this 9 and this 2 that we can combine, right? We can't combine it with the x's, but we can combine unit tiles. So 9 and 2 is 11. We still have negative 5x tiles, so that stays the same. And everything on the right side is the same because there's nothing I can combine there. All right, then, I can see that I can get rid of this 5x and try to combine those. So I'm going to add 5x on both sides. And when I do that, I just have 11 equals 4. Well, let's see. I mean, I could subtract 4 on both sides. I could get this down to like a 0 equals 0. Or I could just say 11 does not equal 4. So I need to put a slash through that. Do not forget to put the slash there because those are not equal. And then we can write no sol or no solution. Okay, that's the one that we know. And the explain why is showing your work. Okay, so we did that part. All right, next problem. It says, Raina says that if x is negative 5, the equation below is true. Her friend Dean says that the answer is x equals 3. Who is correct? And justify your answer. Well, let's work it out to see. So the way that I'm going to choose to do this is, let's see, how do I want to do this today? Let's just plug in for each person, I guess, and see who works out. So I'm just going to use the same equation, and let's try Raina's first. Hers is negative 5. Maybe I should put her name next to it so I remember who's this who's. All right, plus 4. So what I'm doing right now is just everywhere I see an x, I'm plugging in a negative 5, just like that. Okay, now order of operations, right? I know, I'm going to say it again. Order of operations, or PEMDAS, says that we have to do our parentheses first. So that means everything inside this first parenthesis I need to do. So negative 5 plus 4 is negative 1. And there's not really anything I can do inside of these parentheses. This parenthesis here is just kind of showing my multiplication and keeping it separate. So I can leave that for now. All right, parentheses are done. No exponents to deal with. Now I can do my multiplication or division. 9 times negative 1 is negative 9. And 1 I'm going to leave because I'm not doing my addition right now. Negative 5 times 2, right, is negative 10. Then my last step here, 1 plus negative 10 is negative 9. Ooh, that checks out. Nice. Let's just make sure, right, that Dean's not correct here. Maybe I did something wrong, so we'll show his work here. Dean, my old friend, let's try your work. All right, so 9. Now, Dean said 3 would be what x is worth, so I'm just going to plug a 3 in for my x. And here too. Okay, so again, order of operations, parentheses come first. 4 plus 3 we know is 7. Plus, okay, 2 times 3. We want to rewrite our work and really show our steps, okay? I know this, you could probably do some of this in your head, but it's just a little bit easier if you're struggling to do it step by step. Next, multiplication. 9 times 7, right? Is 63. Okay, and then we would do our multiplication here, and that 2 times 3 is 6. 63 equals 7. What? No, I don't think so, Dean. So our answer would be that Raina is correct, just like that. Okay, and justifying our conclusion is showing us these two things right here. All right, next up, finding the rule. Ooh, some review for a pattern. So we know that figure 1 here, let's see, 2, 4, 6, 8, 10, 11 tiles. I'm just going to write that there so I don't forget. And I can see that, let's see, it's giving me like this little graph here. So you might have to zoom in close or look really carefully on yours. I'm going to try to figure out this point because that's going to help me. So figure 6, 7 here. And figure 1, 2, 3 there is where that point is at. Okay, so that tells me, right, that on figure 3 there are 7 tiles. So maybe we could create a little table, right, and fill in this information that we know, a little XY table. I know I'm going to need my 0 number, so I'm going to start at 0 because I know that I'm going to need that for my rule. And then I'm just going to go up 1, 2, and 3. That's as far as I really need to go. I know figure 1 has 11 tiles in it, so I can automatically fill that in. And I know that figure 3 right here has 7 tiles in it. So then I can just say, okay, how many, right, am I going up each time to get there? I could subtract these two and say 7, or 11 minus 7, right, is 4. And then how many jumps is it? Well, there's 2 jumps, so I can divide by 2. And 4 divided by 2 is 2, so that means that my growth is 2. And it's not just 2, it's -2 because I'm losing tiles, or because my line would look in that negative fashion. So when I subtract 2 from 11, I do get 9. And that would help me there. Now if I work backwards here, I would have to add on 2 tiles, so that would be 13. So my rule, y equals, can you see it down there? Yeah. Y equals, what was my growth? My growth was -2, right there. -2, and then I have to add my x. Now my y-intercept, my 0 figure, is 13, so plus 13. And that is my rule. Okay. All right. One more page here with one more question on it. Kind of a long one. All right. Homer, the hungry hippo, is munching on the lily pads in his pond. When he got to the pond, there were 30 lily pads, but he is eating 5 lily pads an hour. Henrietta, the hungry hippo, found a better pond, of course she did, with 38 lily pads. She eats 7 lily pads every hour. So if Homer and Henrietta start eating at the same time, when will their ponds have the same number of lily pads remaining? So what we need to do for this is create a rule probably for each of these 2 hungry hippos. So I'm going to do, let's see, should we do Homer's first because he had the information first? All right, Homer. Here we go. Let's look back at his information. There were 30 lily pads and he's eating 5 an hour. So that means that his rule, right, his growth, how many lily pads is he eating every time? Well, he's eating 5, which means if he's eating 5, that would be negative growth, right, guys? -5. All right, x. Then how many were there originally? Well, there were 30 lily pads in his pond. So we're going to have plus 30. All right, so there's Homer. Now let's do Henrietta. That's a fun name, Henrietta. Okay, let's make a rule for her. Y equals, let's see. She was eating 7 lily pads an hour, so that means that if she's eating them, they are negative growth. And 7 lily pads per hour. And how many did she start off with? Oh, 38. 38 lily pads. All right, so we're trying to figure out how many, or at what point will they have the same amount of lily pads. I'm going to use equal values method here to put them like opposite each other. So I'm going to put my 2 equations opposite here. So -5x plus 30 equals -7x plus 38. Okay. And what I'm going to hope to do is find the solution, right? Find an x value, find a y value. And that will tell me after how many hours that'll be. So now I'm just going to go ahead and solve for x. So to do that, I'm going to try to have positive x values. So I'm going to add 5x on both sides here. That will leave me with 30 equals, let's see, negative 2x plus 38. And then I need to move these other numbers over here, right? This 38, we got to move him over. negative 38. All right, so that leaves me with negative 8 on one side and negative 2x. Then I'm going to go ahead and divide. I'm going to take the negative with it because otherwise it's going to save me a step later on. So negative that. All right, x equals how many times does, well, first of all, I know a negative divided by a negative is a positive, so I don't have to worry about that part. And how many times does 2 go into 8? Well, it goes in 4 times. This right here tells me how many hours, right? Or at what point after 4 hours when they're munching on their lily pads, they're going to have the same amount of lily pads after 4. Okay. Letter B. How many lily pads will be left in each pond at that time? Well, now basically that's asking for my y value. So I need to plug this in to the equation up here and solve. So I'm going to plug it into Homer's and into Henrietta's, and we'll see what we get. So first Homer. All right, his equation, I like to rewrite it. Negative 5x plus 30, just like that. And now we're instead of this x right here, I'm going to plug in a 4. So I rewrite it with a 4 as the x. And then I just solve for y. So negative 5 times 4, remember multiplication before addition, gives me negative 20 plus 30. And when I do that, I get 10. Okay. Now, here's the part that's a lot of people skip. They only check one equation. You have to check both. Okay? Do not just assume that that must be the right answer. This is kind of how we double check it. Henrietta. Got to plug it into her equation as well. If it doesn't work for one, or it doesn't work for both, then something is wrong. All right, negative 7 times 4 plus 38. All right, so remember that multiplication comes first. So negative times positive is negative. 7 times 4 we know is 28 plus 38. And then here, y equals 10. Perfect. All right. Thank you guys so much for watching. I hope that video helps. So we can see basically that this, right, there are 10 lily pads left at that time too, just so that you know what that means. Keep asking questions if you get stuck.